Hello friends, get ready to learn principle of superposition of electrostatic forces. If you have more than two charges at a place, then this means that there are more than one forces acting on the place. Force is a vector quantity, so we have to take the vector sum of individual forces, and the resultant force is said to be principle of superposition of forces in electrostatic. This can be understood by considering here some charges. Suppose we are considering a charge Q0 here, then and a charge Q1 here. So Q1 charge will apply a force on Q0 known as F01. In the same way, suppose we have another charge Q2 here, then Q2 will apply a force here on this charge known as F0 due to 2. So let us draw a parallelogram. Let us draw a parallelogram here. Then this is the force F0 known as resultant force, which is equals to F01 plus F02. So if you have n number of charges, then what will happen? So if you have n number of charges, then force on naught is equals to force on 1 naught due to 1 plus force on naught due to 2 plus force on naught due to n number of charges. This is said to be principle of superposition of electrostatic force. This means that when there is more than two charges, then force acting on a given charge due to another charges are the vector sum of individual forces. This is said to be principle of superposition of forces. This principle can be utilized in different type of numericals. Let us see numerical number 1. In numerical number 1, we are taking a triangle, equilateral triangle. Let us take a equilateral triangle. In this equilateral triangle, let us take three charges Q, 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 equal sign and magnitude. This is the centroid. On this centroid, let us place a charge capital Q. Then the question is, what is the force on the charge capital Q? So for solving this, let us name it A, B, C. This is O. Then force on capital Q due to charge at A is in this direction. This is said to be force on O due to charge at A. In the same way, force on charge Q at O due to charge at B is in this direction. This is said to be force on O due to B. In the same way, when charge at C is Q, so force is in this direction. This is said to be force on O due to C. So net force on charge Q, capital Q, net force on charge capital Q is F, and F is equals to FO due to A plus FO due to B plus FO due to C. This is the forces acting on them. What are the value of the forces? Write the value. The force is K, it is small q, capital Q, small q, capital Q upon R square, because distance AO is equals to BO is equals to CO is equals to R. Let the distance are same, and OA direction, the force OA direction is from A to O. So write here AO cap. In the same way, K small q, capital Q, R square. Write the direction of OB. It is BO cap. BO cap plus write the next force K small q, capital Q, R square. OC, write the direction of OC vector here. So this is CO cap. Take out the common term, which is K Q, capital Q, R square. Under bracket you have AO cap plus BO cap plus CO cap. Now let us name this point as D and name this point at E. Now see here, you are saying that vector, here you have a BO cap. This is a BO cap. So since BO cap plus CO cap can be written as, this is BO is OD, right here OD cap, and CO is OE, so right here OE cap. Now again you are saying that this is in this direction, this is in this direction, this angle is 60 degree, this angle is 60 degree, so the whole angle is 120 degree. So when you draw the parallelogram, you find the direction of these two forces are along in this direction. So this is equals to direction OA cap. OA cap can be written as minus AO cap. So what you have, BO plus CO is equals to minus AO cap. Put here. Therefore, you have force F is equals to K small q, capital Q, R square under bracket AO cap minus AO cap. This will 0. So K Q R square into 0 is equals to 0. So the net force acting on the charge capital Q due to these three charges on the vertices of equilateral triangle is 0, which can be obtained by principle of superposition of electrostatic force. That is, force F equals to force F AO plus F OB plus F OC. Let us have a second numerical for you. In this second numerical, I am giving you an infinite number of charges. Okay, what is the force on a given charge due to infinite number of charges? This means that here I am planning a question like this. Here you have a charge Q equals to 1 coulomb at 1 centimeter apart. This is O, this will be A. 1 centimeter apart, you have another charge Q at 2 centimeter apart, twice. You have point B, another charge Q. Now this is you have 1 centimeter. This is you have 2 centimeter. Now at 4 centimeter you have another charge Q. So this is 4 centimeter in the same, and so on. This means that charges are placed at 1 centimeter, 2 centimeter, 4 centimeter, 8 centimeter, and so on. Next is 8 centimeter. Here is 8 centimeter. Let this be 8 centimeter. This is, and so on up to infinite, Then what is the force acting on this charge due to these charges? So here let this is said to be R1 equals to 1 centimeter. Let this is R2, this is R3, this is R4, and so on. So force acting on this charge Q due to charge at A is F on O due to A direction this side. Force acting on this charge due to charge at B is F O B direction again this side. Force acting on charge Q due to charge at C is FOC direction this side. All the forces are in the same direction. So you can write F force equals to FOA plus FOB plus FOC plus dot dot up to infinite. Here I am not using vector sign because all the forces are along the same direction. So they have same direction of force. Now, what is the value of FOA? FOA is equals to, here it is Q1, this is Q naught, let this be Q naught, and this is Q, Q, Q and so on. So here FOA is K Q naught Q upon R1 square plus K Q naught Q upon R2 square plus K Q naught Q upon R3 square plus dot 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 up to infinite. Take the common term. Common term is K Q naught Q under bracket 1 by R1 square, 1 by R2 square, 1 by R3 square up to infinite. Put the values. So the value of K is 9 into 10 to the power 9. The value of Q naught is 1, and here this is Q. Let the Q is 4 microcoulomb. This is 4 microcoulomb. This is 4 microcoulomb given. So you have Q is 4 microcoulomb, and here this is equals to 1 by 1 square, 1 by 2 square, 1 by 4 square up to infinite. This is said to be sum infinite sum in case of GP. So you know that in the case of GP, infinite sum Sn is equals to A 1 minus R. What is A? First term is said to be A. So first term is 1, right here 1. What is R? R is second term divided by, R is first term divided by second term. So first term is 1, second term is 4. So R is 1 by 4, or you can say that second term divided by third term. So second term is 4 and third term is 16. 4 by 16 is again 1 by 4. So here you have 4, here you have 3. So you have 4 upon 3. So you have 9 into 10 to the power 9 into 4 into 10 to the power minus 6 into 4 upon 3. Cancel this. You have 3. 3 into 4, 12, 12 into 4, 48. You have 48 here. 10 to the power 9, 10 to the power minus 6 is 10 to the power 3 Newton, which you can write 4.8, 10 to the power 4 Newton. Thus, you have seen how you can use principle of superposition of electrostatic forces in various type of numerical. So do like, share and subscribe my channel for upcoming videos. Thank you.